Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from University of Delhi. So students, today we are going to discuss about the module Strength of Composites Continued and Commercially Relevant Composites from the paper Functional Materials. The purpose of this module is to make the students familiar with first the strength of short fibers, second the commercially and technologically relevant composites. So students, let us start with a basic introduction about the module. The commercial application of composites materials in large-scale production started in early 1940s and before 1950s during the period of Second World War with the marine applications in the military. Today, presently, the composite materials are the integral part of many products, including the aerospace, automotive and marine, consumer goods, sporting goods and infrastructure, and in many more applications. The recent developments in the area of the polymer composite manufacturing technology have enhanced the use of composites in wider prospects. The high volume production techniques such as sheet molded components, they have gained higher maturity level and are routinely used in the automotive, consumer and in many industries in a large scale. The advancement in the newer material invention in the field of composite materials and the drop in the price of manufacturing process has enhanced its usage in almost all the industrial sectors. The growth in the field of composite usage is also because of the increased awareness regarding the product information and increased competition in the global market for lightweight components. The composite materials, they have the ability to replace the widely used steel and aluminium and many a times can provide a better performance. A composite materials happens to be the choice of today's industries for many applications. Tensile strength of short fiber composites. As discussed earlier, load to the fibers are transferred through the shear stress on the surface. These stresses build up from the edges and reach a maximum value of fracture strength of the fibers. The length of the fibers must be long enough that the load can build up to this whole capacity. This is also explained schematically in this figure, where it has been illustrated the minimum length requirement for the fibers to carry full load in the composite. So, continuing our discussion over the tensile strength of short fiber composites, the average stress in a fiber can be given by sigma F bar is equal to sigma F multiplied by 1 minus LC by 2L, where sigma F is the fracture strength of fiber and LC is the critical length of the fiber. The composite strength based on this average stress can be given by sigma C is equal to sigma F VF multiplied by bracket 1 minus LC by 2L bracket close plus sigma M prime multiplied by 1 minus VF. Now, here the figure which is shown represents the variation of the efficiency of strengthening, that is sigma C divided by sigma F, with the change in average length of fibers. It is obvious from the plot that 95% of the strength of continuous fiber composite can be achieved in short fiber composites with the fibers only 10 times as long as the critical length. Now let us discuss the various other properties of composites. Composites show excellent properties in terms of first, coefficient of thermal expansion, which can be tuned for thermal management applications. Second, stiffness also results in high resistance to mechanical and thermal distortions. Third, they have excellent property in terms of wear resistance. Fourth, vibration damping. Fifth, energy absorption. Sixth, they have the advantage or the property of self-cleaning or self-lubricating. They have high thermal conductivity. They also have high temperature strength. So, students, till now we have discussed the tensile strength for various composites. Now, let us discuss those composites which are commercially relevant. So, we will be discussing the commercially relevant composites. Ceramic, it is a composite containing the metal matrix and ceramic reinforcement. There are two main classes of ceramics, and these are cemented carbides and oxide-based ceramics. cemented carbide-based ceramics contain one or more carbide compounds bonded in a metallic matrix. So the commonly used carbides are tungsten carbide, titanium carbide, and chromium carbide, and the matrix is usually composed of nickel or cobalt. Commercially relevant composites. Ironically, the reinforcement phases in these cemented carbides ranges from 85% to 95%. Increase in the matrix content leads to decrease in hardness as expected, but it also improves transverse rupture strength. Hence, an optimized ratio has to be found based on a specific application. The variation of the change in hardness and rupture strength with the change in bonding phase of cobalt is shown in this figure. As we can see in this figure, the hardness values are very high, and hence the major application for such composites are in cutting tools, dies, and indenters. Now, students, let us discuss some of the commercially relevant composites. So, we have oxides based ceramides, alumina, Al2O3 particulates. They are used as reinforcing phase in such alloys. MgO particulates are also used. Matrix is usually composed of chromium. Applications includes the cutting tools, mechanical steels, and thermocouple shields. The fiber reinforced polymers or FRPs, they are another technically relevant composites which are made out of polymer matrix embedded with high strength fibers. The thermosetting polymer is usually used as the matrix. So fibers, they are usually made of glass, carbon, Keller, depending on the strength required and the economics. So other commonly available fibers are boron, silicon carbide, alumina, and steel. Commercially relevant composites. In some of the FRPs means fiber reinforced polymers. There are more than one kind of fibers used. That is, technically, we have more than one kind of fiber in it. FRPs are mainly known for their high specific strength and high specific modulus. This table compares the properties of some of the common fiber reinforced polymers with other structural materials, and the four parameters on which basis they have been compared are specific gravity, tensile strength, elastic modulus, and TSSG index. Because of their high specific strength and specific modulus, fiber reinforced polymers are common in wide range of applications, ranging from panels for some equipments to the panels for automotive body and aerospace equipments. Till now, we have discussed the commercially relevant composites. So, students, let us now focus on technically relevant composites, and the kind of composite which we are going to discuss over here is the fly ash composite. Fly ash composites have, although not been commercially exploited, but they are technologically very relevant composites. Metal matrix with the hollow sphere like structures have low densities and can absorb a lot of energy and act as energy dampeners. Fly ash is an ideal dispersoid for this purpose, as it is very expensive, or we can say it is very inexpensive. Fly ash is actually a waste product from thermal power plants and have very low densities. There are various advantages of the fly ash composites, and some specific advantages are they have high specific compressive strength. Second, they have low thermal expansion and hence good dimensional stability. Next is they have good damping characteristics. This is the bar graph which shows the variation for the specific energy for the different composites, which are represented as aluminium foam 1, aluminium A foam 2, syntactic 1, second, third, and fourth. Now here the blue one corresponds to the static, the red the impact, and the green one corresponds to the density. So the maximum impact and the static corresponds to syntactic first. Having the composition of 60 weight percentage of SiO2 and 40 weight percentage of Al2O3. So students, let us summarize what we have learnt in this module. The minimum length required for the fibers to carry the full load in the composite, along with the variation in efficiency of strengthening with the average length of fibers, they had been discussed. We also discussed about the commercially relevant composites like ceramides, fiber reinforced polymers. The technically relevant composites, that is, fly ash composites, were also discussed in this module. Thank you.